Hello and welcome. My name is Grant Malone, and I'm going to be going over how to use our Noraxon Ultium EMG that we have here in the lab. So to start off here, I want to talk about what EMG is. So EMG itself stands for electromyography. Electromyography deals with the detection, analysis, and utilization of the electrical signal from skeletal muscle. Surface EMG in particular records the electrical signal of the muscle via non-invasive electrodes on the surface of the skin above the muscle. So there are several forms or ways of collecting EMG. Surface EMG is the one that we have, and it is the least invasive, meaning that it will not obstruct the movement, and it's pretty easy to actually get going. So here we have a graphic kind of showing you how this works. So you have the muscle, the fat pad in between the muscle and the skin, and then the electrodes placed on the skin. And so the electrodes actually are able to detect the electrical signal that the muscle is basically emitting when actions are performed with that muscle. So in this way, we can think of electrodes like microphones that are used to listen to the muscles. So the Noraxon Ultium EMG, which is what we have, is pictured here on the right, consists of the hardware itself. So you have the gray and blue box there, which actually processes the EMG signal and sends it to the computer. You have your sensors docked in the charging station under that, and then you have the connectors that connect the sensors to the electrodes. So as far as hardware goes, or the hardware that you will need to use the EMG is the Ultium EMG itself. This is connected to the computer via a USB. You'll also need a camera to be able to delineate the beginning and end of each repetition. And you'll need a computer with the software installed. So the software you will need is the Noraxon MR3 software, with MyoMuscle installed on the software as well. Okay, in this section, I am going to go over how you set up the MR3 for EMG. So you'll open your MR3, make sure MyoMuscle is selected. We're going to start off going to Hardware Setup. So this should bring up a pop-up box. You're going to want to select the USB video device or whatever video device you have, and the Noraxon Ultium. You can just drag them over. When you drag over the Noraxon Ultium, you will get an initial configuration screen. You can leave this how it is, unless you have a specific use that you know what these values need to be changed to. So before you close this, we're going to go over to sensors, and we're going to press detect sensors in charger. This will detect all of the sensors that the EMG has, and it will look like this when you are done. After that is done, you can go ahead and press OK. Everything is ready to go. We will then go over to new configuration. I'm going to name this tutorial. Go ahead and press OK. We'll then drag over our devices. So we'll drag over the Noraxon, and you will get this screen. You'll also drag over your video device. When your camera's working, you should see yourself. We'll go back to the Ultium, and it gives us a nice 3D muscle map here, and we can select what muscles we want to observe. For this example, we will just be doing the right biceps brachii, and that will pop up here as EMG1. You want to ensure that you are using the EMG sensor that's labeled with the respective muscle when you place it. And we have up to 8, so you can do up to 8 muscles on here. You can turn around to get a posterior view, and there's some muscles back there as well. So it's really dependent on what you want to use it for. Once you've done that, you can press Start Measure, and it'll bring you to this screen. Once you're here, you can go ahead and activate, and all the software will be ready to go. You can go ahead and prepare the skin for electrode placement. So once all that's connected to your computer and you have MR3 opened up, you are ready to prepare the skin for electrode placement. We'll start off here with hair removal. So ideally, you will have no hair over the site in which you want to place the electrode. If you do have hair, we do have razors that you can shave it off in the lab. Next, we are going to want to use an alcohol wipe or swab to cleanse the skin of any excess dirt or oils that will be over the site the electrode is placed. This will increase the signal that the electrodes pick up. And finally, you're going to want to lightly abrade the skin. We have several options with which you can do this with. We have abrasive pads, abrasive tape, and we have a solution that you can put on the skin and rub on it that will also abrade the skin. Now, you want to make sure that the skin is not overly abraded, so we don't need participants bleeding or anything like that. You just want to lightly abrade the skin. It typically will be a light red or rose color. This doesn't necessarily happen in every participant, um, but generally, you just want that light abrasion to increase the signal that you're getting from the muscle. So once the skin is prepared, we are ready to place our electrodes. So this is going to be different for every muscle as well as potentially every movement. So in a basic form, there are 6 elements of electrode placement. If you are using the EMG for a study, I strongly encourage you to look into the specific electrode placements for the muscle that you are wanting to observe. But these are just general rules that are good to follow for proper electrode placement. So number one is to select the appropriate proximity to the muscle site. So you want to basically minimize the tissue that will be between the electrode and the muscle fiber. This will give you the strongest electrode signal or strongest electrical signal from the muscle. I will note on the side here that in areas that participants may have a lot of excess adipose tissue, this will reduce the signal that the electrodes can pick up. Number two is when possible, electrodes should be placed in parallel or in line with the muscle fibers. So we can see pictured here on the top there are 3 electrodes, and as you can see, they are in line with the direction the muscle fibers are running. So that's how we want them. 3 is to place the electrodes slightly off center of the muscle to avoid straddling the motor end plate region. This can actually interfere with the signal we are getting, so we're going to want to avoid that by placing it slightly off center. So number 4, we're going to want to choose sites that are easy to locate with good anatomical landmarks to facilitate reliable placement. So here on the right, we can see an example here with 2 blue marks being the anatomical landmarks and the yellow X being the electrode placement site. So this is important because if we have a participant coming in over multiple days where we will have to remove the electrode and place it again, we're going to want to put it on the same site that it was before so that any differences in EMG are not due to the difference in placement. Number 5 is to choose sites that are not going to obstruct movement. And this is why I said earlier that electrode placement may depend on the movement that you are having a participant perform. So we are going to want the movement to be performed unobstructed. We don't want skin folds or bony obstructions to be interfering with the electrode or the sensor while the movement is being performed. Finally, we're going to want to minimize interference from other muscles by selecting the appropriate electrode size. So with the Noraxon Ultium, it actually comes with specific electrodes. However, if you do use other electrodes, make sure that you are picking the right size so that they don't cross over other muscles. So here you can see I am taking an alcoholic wipe and cleansing the skin of our participant Aaron here, who agreed to have us filming. I'm doing the biceps brachii and anterior deltoid here. Now I'm using an abrasive pad to lightly abrade the skin. Now before you do either of these things, you want to go ahead and get your anatomical landmarks and basically get a good estimate of where the sensors are going to be placed. Now, on the back of the sensors are double-sided tape, as you can see me taking off here, and these will be put on the skin as well. Once you have your skin prepared, you're ready to place your electrodes. You want to double check your anatomical landmarks to make sure that the skin in which the electrodes are placed will be ready to go. Make sure it's cleansed with the alcoholic wipe and lightly abraded. Again, you are going to want to make sure that the electrodes are in line with the muscle fibers, and then you are ready to place your sensor in a spot that will not obstruct the movement. Once you've placed your sensor on the skin, you can connect the connectors that will connect the sensor and electrode, as you can see here on Aaron's bicep. And once you've done that, you are ready to go. You should be getting signal on your MR3 software. Once we have our electrodes placed, we are going to want to confirm the placements. We're going to want to make sure that they are picking up the electrical activity of the muscle before we go ahead and start collecting data. To do this, we'll go ahead and have the participant perform a movement in which the muscle that we are observing is an agonist muscle in it. So, for example, if we are observing the biceps brachii, we'll have the participant perform elbow flexion and activate their muscle. We'll watch the MR3 software, and we should see electrical signal being picked up by the electrodes. Next, we're going to want to look at camera placement. So we do have a camera in the lab, the Noraxon 125, which is a 2D motion analysis camera that can be used for this purpose. For this demonstration, I'm just using the webcam on my computer. That also can be used. Basically, we just want to make sure that the camera is positioned in such a way so that we can see the beginning and the end of each repetition, so we can distinguish one from another. Here, pictured on the right, is me standing there, and you can see I have the camera placed in such a way that you can see the movement being performed in its full range of motion, and we can see the beginning and end of each repetition. This will be particularly important during analysis, which we'll see why later. When we're setting markers, we're going to need to be able to see the start and stop of each repetition. So before we actually collect data on the movement that we are wanting to observe, we're going to want to perform an MVC, or maximal voluntary contraction, of the muscles that we are wanting to look at. So once we do that, this is about what it will look like. We're doing that. We're getting an MVC to normalize the amplitude on our on the repetitions that we are looking at for actual data collection. So we're going to want to do this before that. Ideally, if you perform an MVC, you will perform the MVC with the movement that you are specifically looking at, as well as at optimal muscle length. Now, this will be different for every muscle. So if you do a little extra research, you can find that out. But in ideal conditions, if everything's perfect, it'll be at optimal muscle length. Here's a demonstration of an MVC. You are typically going to want to have your participant contract as hard as they can for 3 to 6 seconds. Here is a demonstration of the bicep curl. As you can see, the camera is placed in such a way that you can see the beginning and end of each repetition, and it is getting data on EMG. Now, it looks a little rough right now, but there are things that you can do within the software depending on what you are wanting to observe. That will make it a little bit easier to see if you want to look at it while the repetitions are occurring. So once we've collected our data on the movement we're wanting to analyze, we can go into our analysis. So our analysis is going to be dependent on the research question. Noraxon does provide several ways in which we can analyze EMG. The one I am showing you will be the most common one you will use, but there are other options. That's again going to be dependent on what you're using it for, but I'll show you the most common one. Additionally, there are filters in which you can apply to the EMG to make it a little bit easier to interpret. There are several filters on MR3 as well. I'll show you two of the more common ones. So first we have smoothing, and we also have amplitude normalization. Once you have collected your MVC and the exercise you are observing, we're ready for data analysis. So we're going to go up here to database. You'll go under the project and subject name that your data is saved under. We'll start off at the MVC here, so we can double click on that. Press signal processing on the right here. We're under configurations. We'll press make MVC, OK. We'll go back to database. We'll save the changes. We'll now go to our exercise that we've observed. We'll double click on that. It'll bring it up. We'll go to signal processing. I am putting smoothing and amplitude normalization on this. Under amplitude normalization, we will normalize to the MVC stack. We'll press OK. Now we are ready to select when our repetitions occur. So you'll go about to where it starts, and you'll watch the video here. I'll go to half speed, so it's a little bit easier for me to press add to report to add the markers. We'll press play here on the left, press add to report right before the rep, add to report at rep 1, add to report at rep 2, add to report at rep 3, rep 4, rep 5, and the last rep. So now we have markers, which basically will tell the algorithm when each repetition is occurring. So once we have all this, we can go down to report. You'll get a pop-up that will ask you which report you want to do. We are going to do the standard amplitude analysis. We'll press OK. Now we'll get this screen. We're going to want to select by markers and every interval. So it's going to get every repetition. Press next. You can select these if they're pertinent to what you are trying to look at. But for now, we can just go ahead and press next again. And you will get a nice report here, which will give you mean and max of each period. And again, you can manipulate this to get whatever you want. But now you can interpret the data off of the analysis. Now, if you want to export this, there's quite a few options. You can print it, you can make it a PDF, and you can save it. But at this point, it's up to interpretation, and you can interpret the results to hopefully give you some insight on whatever research question you have. So once we have analyzed the EMG data, there are several uses or ways that we can use it to answer different questions that we may have. Now, you can use EMG to answer several questions. I have a few examples listed below, but this is by no means an exhaustive list. So first off is the muscle on or off. So we can perform a movement with electrodes placed over several muscles, and we can see which muscles are being used and which aren't. Additionally, we can see to what degree the muscle is being used. So, for example, in the bicep curl, which we have kind of been showing here, at what point in the movement is the biceps brachii most activated? We can answer that with EMG. We can also look at agonist-antagonist coactivation to see how much the antagonist muscle is activating in relation to the agonist muscle. And this speaks to how efficiently the movement is being performed. We can also look at what movement activates a given muscle the most. So we can put electrodes over several muscles and collect EMG data on them. We can have participants perform different movements, and we can compare the movements to see which one is activating the muscles we are looking at the most. Finally, we can look at the rate of fatigue of the muscle. So if there's a downward trend of amplitude, we can kind of look at how quickly or the rate of fatigue in the muscle. And we can also pair this with things like measures of velocity to kind of give a more comprehensive view of that muscle fatigue. I hope this tutorial gave you a good idea of how to use our Noraxon Ultium EMG. It's a pretty cool piece of equipment. You should come up with some questions that you may want to answer using EMG yourself. And thank you all for watching.